What's going on, everybody? It's O-Rock here, back at you with yet another video for MINGTECH Media. And in today's video, we're going to discuss how to print out the diagonals of a matrix or a 2D array, whatever you want to call it. Now, this problem does require you to think outside the box a little bit and sort of notice a general pattern which you can apply to all matrices. But don't worry, don't fret, don't be alarmed. I'm going to show you how to do all that in this video when I jump into Sketch with you really quick. But first, if this is your first time on one of my videos or my channel, just in general, I make videos for software engineers that help them level up, help you ace technical interviews, help you be an all-around better programmer, lifestyle videos, tutorials, and other things related to software engineering that can help you as an engineer be an elite engineer. So if that's of any interest to you, go ahead and subscribe, hit the bell notification so you'll be notified when I do make content like this. Like, comment, and subscribe, the whole shebang. All right, I'm going to take you to Sketch. All right, guys, so I'm back in Sketch here, and just to kind of outline everything for you, we have the problem statement here, and it says, given an n by n matrix, print all the diagonals. Sorry if there's a little noise in my background. I live in New York City. It's the summertime, and you know, they've just lifted all COVID restrictions, so people are getting a little crazy. But let's get back to this. What does that mean? That means that they want you to print all of the diagonals going upwards. So I'm going to just draw it out for you. So basically, this is how more or less they want you to, this is how they want you to print the matrix. They want you to start from the left hand side here on the first column, and you know, print all the matrices going up like that. And then you go to the bottom, the last row, and then you work your way upwards to the right and print these matrices where my crosshair is pointing. Now, if you haven't already, there are some patterns that I would like to point out. So the first one here is that all the matrices from M to G, so let's start with the letters M through G here. On this side, they're going to start in the first column, right? And they're going to work their way up to, they're going to start in the first column and end on the first row. So you see here, M starts in the first column and ends in the first row. Here, E, the diagonal that traces E and I, E starts here in the first column and ends in the first row, and so on and so forth until you get to G. And then the pattern switches up a little bit. So down here, from R, E, A, T, that's another set of diagonals. These diagonals are going to start in the last row and end in the last column. So this one was starting in the first column and ending in the first row. This one is starting in the last row and ending in the last column. And as you can see, R here, it starts in the last row, ends in the last column. E does the same, where it starts in the last row and ends in the last column, and so on and so forth. So you can kind of see a pattern, right? And you don't want to, you also notice that this G right here, this G actually is the intersection of these rows and columns, and we don't want to double count it. So if we want a formula for all of the matrices, all the diagonals in this matrix, that formula will be, what is it? It's M plus N minus 1, minus that G here. We don't want to double count that. So this right here will get, so we know our number of diagonals. But I want to take a smaller, more arbitrary example and explain this a little more, just so you can see a little bit more of the intuition behind how this problem works. So what I'm going to do here is I'm going to construct a very simple square matrix, a 3 by 3, right? So I'm going to show you a really arbitrary example just so you can see how to think about problems like this. Because what you'll notice is in a lot of these matrix problems where they're asking you to either traverse a matrix or to print out some values in a matrix, they're going to have similar patterns, and your intuition and how you think about these problems is going to be the same. Or very similar, not really the same, but very similar, right? So if we trace this let's say we're trying to find the middle diagonal for this matrix here. This one, oh my God. This example I just drew right here. What would be the intuition behind this? Well, if you take a look at this and you start, this is where you're starting, right? This 2, 0. And we want to just say how we want to, let's say we want to know how we get to 1, 1, right? So what is the difference between those? So your first set of elements is 2 and 0. And then we're trying to get to 1, 1. Right? So you notice in the rows, let's just say this is I and this is J. We notice that from one set of indices to the next, I decreases by 1 and J increases by 1. So I goes to -1 right here for I, and J adds 1. We add 1 to J. J is incremented. So that's J. And we can use this general formula to get from one point to the other. So when we do start in one of these starting points, we can use this formula, I minus 1 and J plus 1, to continually jump through the diagonal until we reach our ending case, or like until we reach our condition, which is ending in the last column, which I'm going to go back to right now, right? So let's take a look at our original matrix. Our original matrix is a 4 by 5 matrix. So there's 4 rows. There's 0, 1, 2, 3. Remember, with arrays, we start with zero-based indexing in computer science. So that's why I've gone from 0 to 3. Then we go from 0, and this is 5 columns, sorry, 5 columns. So it's 4 rows, 5 columns. So it's a 4 by 5 matrix. So 0, 1, 2, 3, 4. Let me erase this actually. All right, so we have this n by n matrix, right? So one of the things that I want you to notice is this, like I said, and it starts in the first column, it ends in the first row, and figure out how we loop through that, or how we like traverse through that. We need a condition that's like I is greater than or equals to 0, right? Because basically how this problem is going to work is you're going to have 2 loops, one for the diagonals that start with the rows here, and then one that starts from here, that starts in the last row and ends in the last column. You're going to have another loop that starts in the first column and ends in the first row, right? So you have to have 2 loops that cover those whole situations, or those 2 situations. And this is going to be the condition of a while loop. And why is it the condition of a while loop? Well, there's going to be an outer for loop for each one of these loops, and that outer for loop is going to be responsible from going for this first loop right here, because remember I said there's going to be 2 loops. There's going to be loops, the loop that starts for all the elements going upwards from the first column, and then there's going to be another loop that starts in the last row going upwards, printing those diagonals, right? So what the for loop here is going to do, the outer for loop is going to be responsible for going down through these rows. So we're going to, the condition for that loop, and you're going to see that in a second. The condition for that loop is going to be m minus 1, which is just the rows minus 1. So that's 3. So it's going to go from 0, 1, 2, and 3. So it's going to be m is, we're going to iterate from I is less than or equals to m minus 1, or whatever variable we decide to use. So let me just erase it. All right, so we're going to, that condition is going to be, let's say k is less than or equals to m minus 1, right? And this m minus 1 is the number of rows minus 1, so that's 3. So you're going to go from 0, 1, 2, 3. And the inner loop, there's going to be a for loop on the outside, and there's going to be a while loop on the inside, right? The outer loop is responsible from going from row to row until it reaches 3. The inner loop is responsible for traversing. This is when we're going to use this logic here, this I minus 1, j plus 1. This inner while loop here is going to be responsible for going up and printing the values. So starting here, print, then go up, calculate that math, print, go again, print, it reaches its termination condition, goes to the next, it pops out of this while loop, goes to the next iteration in the outer for loop, and then it's going to go down to G, start, go all the way up, boom, it's going to be done. We're going to break out of that loop, and then there's going to be another for loop further down in the code that is going to be responsible for iterating from left to right in the last row. So that condition will probably be something like what j is less than or equals to, can't see, n minus 1, which is the number of columns minus 1. And again, we're stopping in the last column, and that's n minus 1. So there's 5 columns. So n minus 1 is 4, sorry, because n is 5. So n minus 1 is 4. So the outer loop is going to be responsible for going through those, going up until 4, but we don't want to start at 0. We actually want to start at 1. And you're going to see this a little bit later. I'm going to explain this more in depth when I write the code. But we want to start at 1 because remember that extra diagonal? If we started at 0, we would print this same diagonal again. So we don't want to start at 0. We want to start at 1, which is this column here. And then we want to print everything, all the diagonals going upwards from left to right. So that's why we're going to start at 1 in the top for loop, right? In the inner while loop, it's pretty much the same logic. We're going to use this formula here, this I minus 1 and this j plus 1 to keep getting to the next set of indices in the matrix until we reach our termination condition, which is j is less than n minus 1 or less than or equal to j n minus 1. So those conditions will hold the same for both the inner and the outer loops. Alright, we're probably going to be using different variables for these. Like this will probably be like a k and this will be a j, but that condition will be the same. Again, we're stopping at the 4th column, so that's why we iterate from left to right starting at 1. So it's going to go 1, 2, 3, 4, but we're also ending in the 4th column as well as we go up and to the right and print out our diagonals. We're ending in this column. All our diagonals, as you notice, they end in this column, right? So that's the intuition behind that whole, let's just say this is k. That's the intuition behind k is less than or equals to n minus 1 and j is less than or equals to n minus 1. So the for loop, that's going to be outer for loop, that's going to be the condition for you to go from left to right from each one of the columns. And the inner while loop, that's going to incorporate this math, this formula here that allows you to go up and to the right and print out these diagonals. So I've talked a lot, but I'm going to write the code for you and then go through it, and then you'll definitely understand a lot more what I'm talking about. I just wanted to talk about the intuition behind the code so you know how to think about these types of problems. Alright, so we're back in Sketch here, and what we want to outline is basically just some of the things we talked about before, just so you're clear on that. So again, like I've stated before, there's going to be 2 for loops, and the first for loop is going to cover all the diagonals whose first element starts in the 1st column, And the second for loop is going to cover all the diagonals whose first element starts in the last row and ends in the last column. So let's walk through step by step. We're gonna set k is equals to 0 here, because we're starting at 0, 0. So we're gonna set k is equals to 0. And we're gonna go from k is equals to m minus 1. Remember, the outer loop is tasked with going, for the first loop, is tasked with going from 0 down up until 3, right? So that's why there's this logic of m minus 1, because you notice the m is 4 and the n is 5. So m minus 1 is 3, so it's going to go from 0 down to 3, right? And then k plus plus. So that's the outer for loop, right? Should write that there. So the inner while loop, there's a condition of I is greater than or equal to 0, because we never want to go below 0, because 0, remember, these things, these diagonals for the first for loop, they're starting in the first column and they're ending in the first row. The first row is going to be 0. That's why we don't want it to go below 0. It can be less than, it can be greater than or equal to 0, but it can't be less than 0, right? And if it's less than 0, as you'll see in a second, we'll jump out of our condition and then go to the next iteration in the outer for loop. So the inner while loops are just tasked with printing like just a diagonal. The outer for loop is for the traversing downwards or from left to right in the case of the second for loop, which we'll get to in a second. So, all right, it's going to print out ij. And then that's where, once we printed out a single element, we want to get to the next element. So that's where that little bit of math and that formula that we sort of constructed earlier from our arbitrary example comes into play. So we just set I is equal to I minus 1 and j is equal to j plus 1. All right, so let's see for this matrix what will happen. So, I just took the bulk of the important logic and wrote this out here. When you're writing a function, people have different preferences and how they do things. Some people might, ask the caller of the function to pass the rows and the columns. Other people might do the calculations for you in there with they find the length of the first element in these 2D array, because matrices are 2D arrays, and they find the length of the first element, which is like the first array, and that will be the number of columns, and then the length of the outer array will be the number of rows and whatnot. So that's how they calculate that. So you can choose to do either or. I didn't want to fixate on that. I just wanted to show you guys the bulk of the logic and the most important bits of the logic, right? So that means I is going to be equal to 2. Oh gosh, jumped ahead of myself. So I is going to be equal to, and j is going to be reset to 0. So that's this element here. So as we break into this while loop, like I said, 2 is greater than or equal to 0. We're going to print 2, 0, which is this element D here. And then we're going to subtract 1 from 2. That's going to give us 1. And then we're going to add 1 to 0, which is going to give us 1, which is this element here, right? So we're going to get that element here at 1, 1, and we're going to print that. We're going to keep going through that loop, and then going through the loop again. So is 1 greater than or equal to 0? It is. We print that matrix, blah, blah. Then when we subtract 1 from the I, we get 0, first row. And then we add j, we add 1 to j, that's 2. So remember, plus 1, and then we go minus 1. So this is 0, and this is 2. What is the last element in this diagonal? 0 and 2. So that's how we get that last element. I'm not going to do this row because that's a longer row, and I want to keep this tutorial very concise. Now, remember when I said earlier, before I wrote the code, motorcycle passed by. There's a lot of bikers in my neighborhood. Yeah, but remember when I said earlier, when I wrote the code, K is going to start from 1 here, and this is why, because we've already printed this diagonal. Even though we didn't go over it, we've already printed that diagonal. So what we want to do is, and we need to go from left to right at each, and starting at each column here, and print the diagonals going upwards, right? Print these diagonals. So we have to start at 1 because that's where this this R starts. It starts in this column. And again, we don't want to double print or double count this diagonal because this is an intersection between both these rows and these columns here. All right, so that's the intuition behind K is equal to 1. Now K is less than or equals to n minus 1. Remember, n is the number of columns, which is 5. So this will be 4. And why are we using that, and why are we iterating up until that? All right, so basically the intuition behind this K is equals or less than or equals to n minus 1 is this. We want to go from 1 to 4, and this is the outer for loop, which is tasked with going from column to column, and then the inner while loop is going to go from index to index and print it out with that bit of math and other logic we've got going on the inside of that while loop. This little bit of code above these while loops is just to reset it before it goes back into the while loops again. I explained this here, and it's pretty much the same logic. So that's the intuition behind that n minus 1. But we've also got while j is less than or equals to n minus 1. And the reason being is for this inner while loop, we're stopping at n minus 1, which is 4, which is the last column. 4 is the last column here. And if you notice, this is where, let me just use a different color. Use like a red. If you notice, this is where all of these diagonals stop. They stop in this row. This column, sorry. They stop in this column. They stop in this 4 column. So we have to set our condition that j is less than n minus 1, n being a column, so that's 4. So the j, which again, the ji is the rows, and j is the column. So we can't go beyond that. We can't go beyond 4. So it's gonna the last elements are gonna be like 0, 4, 1, 4, 2, 4, and 3, 4. So we can't go beyond. That's where the last element stops. So that's why this j is less than or equals to n minus 1 makes sense. And then we print it out, and then we do the same bit of logic, just like above here. So I'm going to take you through a couple diagonals just so you can see. So we're at 3, 1, right? So k is equals to 1, k, up until k is less than n minus 1. Again, that's 4. So, oh yeah, I didn't explain this part. The I is equals to m minus 1. Why is I equals to m minus 1? Remember, m is the number of rows, and we're starting on this bottom row, and we're iterating and going up until this last column here. So when k is going to be the variable that changes. That changes when you reset everything. Just like here, the I was the variable that changes, right? And J stays the same when you reset. But down here, it's the reverse. I is the one that stays the same. So this stays the same. And J is the one that changes, right? So here, the column wasn't really changing when we reset because, again, everything starts in this first column. Down here, the row is not changing because everything starts in this last row. Hope that makes sense. But J, the columns are changing because, as you can see, these columns do change. So we start at 3, 1, and we go through the loop. K is equals to 1. I is equals to m minus 1. Again, that m, the rows, it's 3, so it starts here, down here. And then J is equals to K. Right now, what is K? K is 1. Right here, we set K equals 1 because we're starting in this first column. So that's why we start, or that's how we get to start at 3, 1, right? That's how we start at 3, 1 for this bottom set of diagonals that go up from left to right. And so we go through our conditions, and is J less than or equals to n minus 1? Again, the n minus 1 is 4. Is J, which is now 1, is that less than or equals to the n minus 1? It is. So what we're going to do, we want to print out that current element, and then we're going to subtract 1 from I and add 1 to J. So that is going to be what? We're going to have ourselves 2, 2. And if you go up and you see that A, you notice that it's at 2, 2. So we go through and we check these conditions again, that J is less than or equals to n minus 1 again, which is, 3? Oh no, n minus 1 is 4, sorry. N minus 1 is 4. So it stops at that 4, so 2 is less than that. You keep going through. Again, you subtract I minus the 1, and then that's going to give you 1, and then add that's going to give you 3. So where is the next one? It is 1, 3, this M right here. We were at the A before, and then before that we were at the R. So that's 1, 3. And then so on and so forth. If you do that math again, what is that going to be? 0, which is the first row, and that's going to be 4. And remember, it stops at 4. So 0, 4. This is where it terminates. It goes to the next iteration in the for loop, which is this 2. Remember, we started at 1, so now it's at 2. So it's 3, 2. Remember, the columns are changing. The row isn't changing because we're staying at this last row to begin, and then we're iterating up and out to the right. So these rows are not changing for the second for loop, but the columns are. So we're using the outer for loop to iterate through the columns, or to get the next index on columns, because that's actually changing. So this changed. And that's basically the intuition behind it. So I really, really do hope I did explain this well. I tried to over explain it many times, and I'm going to make some edits to make this shorter and more concise, but I wanted to include a lot of information here on how to solve this problem because it took me like a couple days to solve this problem initially. But I wanted to over explain it so you can understand what happens at each step. But if you made it this far, I appreciate you checking out the video and rocking with me to the end and going through the problem with me so you can better understand it. I hope this video has helped you out a lot. Like I said, this stumped me when I first started. But that's all for this video. Like, comment, and subscribe for more content. And thanks for watching.